Hi, and welcome to our section on microservices. In the previous section, we looked at reactive programming and the ReactiveX framework. In this section, we're going to take a look at what a microservice is, why we might want to structure our programs as microservices, and how to use some common Python tools to create them. In this video, we're going to be looking at microservices from a conceptual perspective. When we need a new feature for a project, there's a temptation to just add it to the project's main program and continue on from there. Sometimes that's entirely appropriate, but in many cases, it's actually better to make the feature a distinct program in its own right. There are several reasons why a feature might be better off with less tightly integrated into the system. The most important ones are flexibility, scalability, and durability. It's easy to understand the flexibility benefit. Modular programs inherently consist of a bunch of modules that we can reuse in the future. So, every time we write our code as an independent module with a well-defined interface, we're making an investment that will make it easier to adapt to the changes that come in the future. The scalability advantage comes into play when our modules are actually separate processes, allowing separate instances to be run on multiple processors, with the load balanced across them. The durability advantage also comes into play when the modules are processes, because processes are mostly safe from the bugs that crop up in other processes. And because processes are mostly safe from the bugs that crop up in other processes, and because a failed process can often be restarted without needing to take down the whole system. Those advantages all apply to many circumstances. They're the same advantages that drove the development of microkernel operating systems back in the 1980s. But the term microservice specifically refers to applying them to web applications. This means that instead of writing one server program that handles all of the logic of our web application, we'll write one or more servers that handle most of the front end and call on a bunch of different special-purpose servers to handle all the back-end work and any remaining parts of the front end. Each special-purpose server should do a single well-defined job as well as possible and not care about anything else. Those special-purpose servers are microservices. And usually, using a microservice design gives us better uptime. Uptime lets us scale up to take advantage of a server farm or cloud hosting system and helps us adapt to the ever-changing web more quickly. So to recap, when our server is actually a collection of servers, each of which has a narrow and well-defined job to do and does only that, we're using a microservice architecture. As an added benefit, the interfaces between our microservices constitute an application programming interface. So if we get to a place where we want to expose an API for the world to use, all we have to do is adjust our authentication and authorization code, and possibly our routers, to allow external entities to access some of those interfaces. In this video, we've looked at some of the advantages of process-based modularity and seen how applying those principles to web applications results in a microservice architecture. In the next video, we'll learn how to use the Flask package to quickly and easily construct a microservice that uses HTTP and representational state transfer, better known as REST, to provide its interface.